Welcome to Mathematics for SS1. The topic for this week is called Deductive Proof. Now, before you listen or watch this video, make sure that you have written your notes for week 3 and 4 and also for week 5. I sent both notes together in the classroom. So you see the notes there for week 3 and 4 and then the note for week 5. So let us continue. Now, when we are talking about deductive proof, we are talking about giving proofs or showing the proof of the interior and exterior angles of a triangle and polygon. I repeat, we are trying to show you the interior and exterior angles of a triangle and polygons. Now, if I ask you what is the meaning of interior, interior means the inside of a particular item. Exterior means the outside of a particular item. So when I say interior angle of a triangle, I mean the inside angle of a triangle. And when I say exterior angle of a triangle, I mean the outside angle of a triangle. And we know about polygons. Polygons are shapes that are more than 4. Shapes that are more than 4. So let's go on. We are going to be looking at different theories on this particular topic. Theory 1. Note this. Sum of angles in a triangle is 180 degree. Look at this example. This is a triangle ABC. So the sum of the angles in this particular triangle will give me 180 degree. They are called interior angles. A1, B1, C1, interior angles of this particular triangle. That is to say, A1 plus B1 plus C1, when I add 3 of them together, I should be able to get 180 degree. Given the triangle above, ABC, angle A is A1, angle B is B1, and angle C is C1. When I add the 3 angles together, I got 180 degree. As you are seeing in your notes, that is A1 plus B1 plus C1 equal to 180 degree. That is a proof, and I told you that it is called interior angles of a triangle because these are angles inside a triangle. Let's go to number 2. A1 is equal to A2. A1 is equal to A2. It is called alternate angles. Go to the shape. A1 is equal to A2. It is called what? An alternate angle. And don't forget rules. Alternate angles are equal. B1 is also equal to B2. They are called corresponding angles. Go back to the diagram. B1 equal to B2. You can see it is corresponding. This particular angle looks exactly like this particular angle. You can see the shape. B1 looks exactly like B2. It is called corresponding, and corresponding angles are equal. And also alternate angles are what? Are equal. That's why A1 is equal to A2. Now, if A1 plus B1 plus C1 equal to 180 degree, don't forget A1 and A2 is the same thing. B1 and B2 is the same thing. Therefore, C1 plus A2 plus B2, when you add these 3 together, C1, A1, B, C1, A2, and B2, you should be able to get 180 degree. Now, this rule says that sum of angles on a straight line equal to 180 degree. Look at it here. C1 plus A2 plus B2 is 180 degree, which says what? Sum of angles on a straight line equal to 180 degree. Don't forget, it is on a straight line. Now, there's something I want you to also know. Looking at this too, if I say ACB, angle ACB, you go back to the diagram. Angle ACB, I'm talking about angle C itself. That's why you can see a small N which represents angle on top of the C. You can see a small n which represents angle on top of the C. Angle ACB plus angle BAC plus angle ABC equal to 180 degree. What I'm saying here is that angle C plus angle A plus angle B equal to 180 degree. It's still the same thing. I'm just giving you the interior and exterior angles of a triangle. Now let us put it into practice. When I mean practice, let us quickly give an example. Looking at theory 2. The exterior angles of a triangle is equal to the sum of the opposite interior angles. This is another theory. I repeat, the exterior angle of a triangle, when I mean exterior angle, I mean the outside angle of a triangle, is equal to the sum of the opposite interior angles. Look at this diagram. This exterior angle, this particular angle you can see here, is an exterior angle. It means it is an angle outside the triangle. The exterior angle, what you get here, is equal to the sum of the opposite interior angle. That means these two, they are opposite. A and B is opposite this particular exterior angle. That means if you add A and you add B, you will get the same thing as this exterior angle. Let us put this particular test, this theory, to practice by looking at a question. Therefore, using this particular question 1 in our notes, you can look at the interior angle of this particular triangle. The interior angle here is 80 degree for angle A, 30 degree for angle B, X degree for angle what? C. That means the interior angles of this particular triangle ABC is 80, 30, and X. Don't forget that theory says that the exterior angle of a triangle is equal to the sum of the opposite interior angle. That means when you add 30 and 80 degree together, you should be able to get Y degree. Let us prove it. Since we say angle A plus angle B plus angle C is equal to 180 degree, angle A, this particular angle, plus angle B plus angle C equal to 180 degree. Therefore, let's find angle C, which is X degree. That's why I put angle ACB. ACB as in ACB. This particular angle, angle C. Therefore, to get angle C, you say 80 degree plus 30 degree plus X degree equal to 180 degree. 80 plus 30, 110. You will subtract 110 from 180. You find out that X degree, which is angle C, is 70 degree. So this particular angle, angle C, is 70 degree. Now, if this particular angle is 70 degree, don't forget our theory says that the exterior angle of a triangle is equal to the sum of the opposite interior angle. Now let us see whether Y will still give us the same answer as when we add 80 plus 30 degree. Now remember that sum of angles on a straight line equal to what? 180 degree. That means when I have this particular X and I have this particular Y, and then I add X plus Y in this straight line, this particular straight line, I should be able to get 180 degree. That means X plus Y should give me 180 degree. Remember now, what is X? Remember, we found the value for X, the deductive proof for X, using sum of angles in a triangle to find X. And we note that X was 70 degree. Now, using the rule, sum of angles on a straight line, we just say angle ACX, angle ACX, which is Y degree, plus 70 degree, which is angle ACB, equal to 180 degree. Therefore, angle ACX, which is unknown, this is angle ACX, so ACX, it is unknown, which is Y. So angle ACX is unknown, will give me 180 degree, sum of angles on a straight line, minus 70 degree, which is the value for X. Therefore, 180 degree minus 70 degree will give me 110 degree. Therefore, angle ACX is 110 degree. Now that proves our deductive point, which says angle at the exterior angle, or the exterior angle, is equal to the sum of the opposite interior angle. Therefore 80 plus 30 is 110, and this particular angle Y is also 110 degree. Just go through your notes. You will see the way I give you the deductive proof of each angle, ACX, ACB, ACDs. You understand and trace it to the diagram. Now, since we've dealt with the deductive proof of a triangle using our interior and exterior angles, sum of angles in a triangle equal to 180 degree, sum of angles on a straight line equal to 180 degree, the exterior angle of a triangle is equal to the sum of the opposite interior angle, and then we've solved that of triangle. Let's move to the next headline, which says polygon. And what is a polygon? A polygon is a closed shape that has 3 or more straight sides. I repeat, a polygon is a closed shape that has 3 or more straight sides. Examples of polygons include triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. Now, this triangle is 3 sides, a quadrilateral is 4 sides, a pentagon is 5, and so on and so forth. You see that in your notes. Now, there's something you need to know for the formula for these particular polygons. The sum of the interior angles, when I mean interior, don't forget the word interior. Interior means inside. The sum of the inside angles. Anytime you hear me say interior, the sum of the inside angle. If you hear me say exterior, I'm talking about outside angle. So the sum of the interior angles of any given shape, that I put N shape convex polygon. The sum of the interior angles, the sum of the inside angles of any polygon, whether 3, 4, 5, 6, or 7, the formula is 2n minus 4 multiplied by the right angles. That is, the formula is to get the sum of all the angles inside that polygon, you use 2n minus 4 times 90 degree. That's why that 90 degree represents right angles. If you don't want to use that, you can also use this. Sum of angles in any polygon shape, in any side that has more than 3 shapes. You can also use n minus 2 times 180 degree. So whichever way, whichever formula you want to use, 2n minus 4 times 90, you get the total sum of angles in that polygon, or you use n minus 2 times 180 degree. Now there's something I wrote here that I would like you to know. Also note, sum of angles at a point or sum of angles in a circle is 360 degree. Sum of angles in a circle is 360 degrees. Sum of angles at a point, 360 degree. Because 360 degrees is the same thing as 4 right angles. When you add 4 right angles together, you get a circle. An equilateral triangle, all sides are equal. All sides and all angles are equal. It's called equilateral triangle. As I drew it here, all sides are equal. This side is equal to this and this. An isosceles triangle, only 2 sides is equal. An isosceles triangle, only 2 sides is equal. A scalene triangle has no equal side. So we need to know this. By now we should all know this. Equilateral triangle, isosceles, and scalene triangle. Now this is all about polygons. Polygons are shapes that has 3 or more straight lines. Now we'll solve a question on polygon. Now let's solve a question on polygon. Example 1. ABCD, you hear the word ABCD, means that it has 5 straight lines. And a shape that has 5 straight lines is called a pentagon, as I gave you in the notes. ABCD is a regular pentagon. The side AB and the side DC are produced to meet at X. When you read it, look at your diagram. The side A and B and the side D and C, they are produced to meet at X, as you can see it in the video. Now they are asking you, show that angle BDX has two equal angles. Show that angle BDX has two equal angles. Now the question you need to ask yourself is, where is angle BDX? Where is the triangle BDX? This is the triangle BDX. BDX. Have you seen it? BDX. Show that triangle BDX has two equal angles. That's what they're asking you to find now. So to get this particular question, you say solution. In this particular triangle that they asked us to show, we know that BXC, that means the triangle BXC, in that particular triangle BXC, Y is equal to Z. Look at it very carefully. In the triangle BXC, this small y is equal to this small z. Why? Look at it properly. How can y be equal to z? Y is equal to z because it is an isosceles triangle. This particular angle y is equal to this particular angle z. It is an isosceles triangle. And I told you earlier that an isosceles triangle is a triangle that has two equal angles and one angle that is not equal. In this particular case, angle x is the one that is not equal, but angle y and z is equal. Therefore, and if y equal to z, don't forget, sum of angles at a point is what I told you earlier. Sum of angles at a point is what? 360 degree. And this particular shape given to us is called a what? Because it has 5 sides, it's called a pentagon. Therefore, sum of angles in this particular shape, in this particular point, is 360 degree. Therefore, since y is the same thing as z, you will now say 360 degree divided by 5. 360 degree, sum of angles at the point, 5, number of side of the pentagon. So therefore 360 divided by 5, you have 72. Therefore angle y and z is 72 degree. Now if y equal to z and if both of them are equal to 72 degree, how do we find x? How do we find x? If y and z is 72, how do we now get x? Remember that sum of angles in a triangle, this particular triangle says I am 180 degree. So if here is 72 and here is 72, how do you get x? Simple. Just say sum of angles in a triangle is 180 degree. Therefore, x plus 72 equal to 180 degree. X degree will be 180 degree minus 144 degree. X degree is what? 36 degree. Have you seen that? X degree is 36 degree. Now, remember the question. The question did not ask us to find x. The question says that show that BDX, triangle BDX has what? Two equal angles. That's the real question. Show that triangle BDX has two equal what? Angles. Now, let's go back to what we have. Therefore, since we know that y and z is 72, true or false? True. Y and z is 72. Remember the rule. Remember the rule of triangle. I told you that the rule of triangle says sum of angles in a triangle is 180 degree. And then the exterior angle is equal to the sum of the opposite interior angle. Can you remember? If you can't remember, please wind back this video and go and listen to that particular point again. The exterior angle here, y, is equal to the sum of the opposite exterior angle. That means y is equal to a plus c, because a plus c are opposite interior angles to this particular exterior angle y. I'm too fast. I'm trying to so that I don't waste much time in this video, but please try and read your note. Read your note. You will see the way I explain it very, very well, but also listen carefully. Y is an exterior angle to this particular triangle BDC. This is a triangle BDC, but Y is an exterior angle, means outside angle from that triangle. Therefore, since Y is exterior angle, Y here is equal to the sum of the opposite interior angle. That's why I wrote here Y equal to A degree plus C degree. Therefore, Y is 72 degree. Don't forget we got Y and Z before using 360 divided by 5. Therefore, if Y is 72 degree, Y equal to A plus C. What do we now do? Since A and C are equal, they are equal of course, because the sum of the opposite interior angles are always equal, because it's an isosceles triangle. You can see it here. A and C makes it an isosceles triangle. That's why you see in this particular triangle, you can see this mark, and this mark. This particular mark points to C, while this particular mark points to A, to tell you that A and C is equal. That means this particular triangle BDC is an isosceles triangle. Therefore, since A and C are equal, you just say 72 divided by 2. You get A or you get C. And then 72 divided by 2 is 36 degree. Therefore, A and C is 36 degree. Going back to the diagram, the example, A is 36, C is 36, Y is 72. That's the rule. The exterior angle is equal to the sum of the opposite interior angle, 36, 36, 72. If Y is 72, Z is 72, is an isosceles triangle, and this X is 36 degree. Now, this has proven our point that C is 36, A is 36, Y is 72, Z is 72, X is 36. Therefore, triangle BDX, as given in our question, has two equal angles. This angle A is 36, angle X is 36. That means they have two equal angles. A and X, they are equal to themselves. Look at it in your notes. That's why I wrote A and X are equal, and it proves our point that the triangle BDX, let's go back, it proves our point that the triangle BDX has two equal angles, A and X. Very simple. Now please watch this video over again. Please watch it one more time and listen attentively, and also look at your notes while you are listening to the video. Don't rush, you understand it. And in order for you to understand it on your own, also I gave you an assignment. Please practice this in your notes, not on the portal. Practice it in your notes to get acquainted to it. Practice question 1 to 5 in your textbook. You have a textbook, question 1 to 5 of exercise 2A, page 321. You will see it there in your new general mathematics, page 32, exercise 2A, question 1 to 5. Practice it on your own, and then you will understand. And also please read your notes so you can understand better.